So this lab is going to involve measuring light intensity. And to do this lab, we're going to be using this device here. It's the Vernier device, the light intensity probe, that we're going to set on the most sensitive setting. And what we're going to do is we're going to put an image on the screen of this computer, or I am, and I am going to turn out all the lights, and I'm going to remove all the other computers so that only the monitor will be in here. And once it's dark, darker than this even, what I'm going to do is I'm going to gradually move the sensor away from the monitor when I'm looking at the point, and we're going to see how the light intensity decreases as I get further and further away from the point. And we're going to see that it should have a 1 over r squared dependence, kind of like a point for an electric field. And light actually consists of electric and magnetic fields, so there's some rationale for why it should drop off as 1 over r squared in terms of the brightness. All right, after I do it for the point, I'm then going to do it for a line and make the line white. And I'm going to gradually do the same thing. I'm going to back the light sensor away from the screen and make a series of measurements from very close, like this, right here, to much further away. And I'm going to record what the brightness is on each of those measurements. And we'll see, you might expect that the brightness is going to drop off less quickly for a line as it would for a point. The same is true for a line of charge, although we didn't talk about that as much. The electric field for the line of charge drops off less quickly than the electric field for the point of charge. Finally, and this is the one that you will also relate with, we're going to be dealing with a plane of charge. In other words, I'm going to illuminate the whole screen here. And I'm going to back off the sensor. And we're going to see how the illumination is going to decrease as I back the sensor away. And as you might expect, for an electric field, when I'm near the sensor, whether I'm half a centimeter away or 1 centimeter away or 2 centimeters away, really shouldn't matter. Because to the sensor here, it looks like an infinite electric field. So in that case, just like an infinite plane of charge, doesn't matter where you are located away from the field, what distance, it shouldn't matter. You'll still have the same value of electric field, no matter how far you are from the plane of charge. In this case, of course, eventually when you get far enough away, it no longer looks like an infinite plane of charge. It eventually starts to look like a point of charge, and it'll decrease as 1 over r squared. We won't get that far away, but you should see it be fairly constant, at least for the first few measurements when it's up close. That's the point of today's lab, and I'll be making the measurements shortly. All right, about to start the collection here, and right now the photogate, or the photosensor, light sensor, is right up against the computer screen on the dot. I'm going to press collect and see what we get. Around 100 lux. Press stop. I'm going to average over this region. So I take that to be a mean of 100.1 lux. Remember, lux is a unit of brightness. Now I'm going to start backing up the photocell gate, or call it the photocell gate, but it's the light sensor, away from the dot on the screen. Okay, I'm now half a centimeter away. Pressing collect. And stop. And now we see we're at about 48.33 lux average. Now we're 1 centimeter away from the single dot. And of course, as expected, the brightness went down. And I should have said that the brightness went down to 27.6 lux at 1 centimeter distance. Okay, we're now 1.5 centimeter distance. Pressing collect. You see again, the brightness went down as we would expect. We're at a point, by the way, 1.5 centimeter distant from a point. Forgot to report the mean at that. At 1.5 centimeters, the mean was 18.5 lux, in case you can't see it on the graph. Now I moved it to 2 centimeters, and you can see it's going to be close to 14 lux. So I'm going to press collect. I'll try to remember to give you the average before I pause the video. Okay, the average, press stop. It's about 14.1 lux at 2 centimeters. We're at 2.5 centimeters here, and I will record. Looks like it's around 10.5 lux. Actually, the mean here shows 10.6 lux. Okay, now we're at 3 centimeters. Pressing collect. I see that we have an average of around, let's see here, 7.9 lux. Okay, now I'm at 3.5 centimeters. And let's see what we got here. Of course, it's gone down a bit. 3.5 centimeters. Stop. The average is 6.5 lux. We're now at 4 centimeters distance from the dot. Pressing collect. We are at 5.4 lux. Now at 4.5 centimeters, and the lux is going to be similar. It's going to be around 4.5. Let's see what we got. Okay, the illumination is 4.7 lux. Okay, now we're at 5 centimeters. Illumination's certainly gone down. Looks like we are at 4.1 lux at 5 centimeters. I'm going to repeat 5 centimeters because I actually had a light on in the back of the garage when I was doing that. So when I repeat it, it's slightly lower now because stray light enters the light sensor, which we don't want. Ideally, we want all the light to be from the dot on the screen. And, oh, still got about 4.1 lux. So I'll go with what I had, 4.1 lux. Now at 5.5 centimeter distance, and the illumination, again, seems to have gone down a little bit. At some point, we're going to be getting just the stray light from the room. There is some in there. Even from the screen, the dark part of the screen, I didn't cover it. And even the dark part has some illumination. But we're down to 3.5 lux at 5.5 centimeter distance. 3.5 lux. Okay, now we're at 6 centimeter distance. And let's see what we got. 6 centimeter distance. We are at 3.4 lux average. We're starting to get to the point where we're at the background. When we get to there, I will stop. Okay, we're now at 6.5 centimeter distance from the screen. Collect. Scraping the bottom here. 6.5 centimeters, 3.1 lux average. Okay, 7 centimeter distance. Let's see what we're at. Looks like it's still gone down. 7 centimeter distance, we are at 2.8 lux. I'm rounding it to 2 sig figs. 7.5 centimeter distance. Still going down ever so slightly. All right. And it looks like 2.7 lux at 7.5 centimeter distance. Now at 8 centimeter distance. Eight centimeters, 2.5 lux. Okay, we're now at 8.5 centimeter distance. .4 lux. 9 centimeter distance on the single dot. And we are at 2.3 lux at 9 centimeter distance. .5 centimeter distance. Let's see what we got here. Just about done with the single dot. .5 centimeters, we're at 2.2 lux. This is the last one I'm going to do for the point. 10 centimeter distance, pressing collect. We are at 2.1 lux. So the next one will be the line.